As mining operations evolve, Central Asia stands at the forefront of innovation, embracing digitalization, automation, and environmental management to enhance efficiency, safety, and sustainability. In this session, industry experts will share successful case studies demonstrating how advanced technologies are shaping modern mining practices. A key focus will be the integration of international standards and best practices to boost the region's competitiveness on the global stage. From AI-driven resource optimization to environmentally responsible extraction, this discussion aims to provide actionable strategies for the future of mining in Central Asia. Let's begin.
Good evening, everybody. I'd like to thank all the patient ones who have survived to this session. As Arthur announced, we are going to have a small entertainment at the end. The most attentive ones, we have prepared some small gifts. So, you need to watch this session very closely and attentively. And at the end, I'm going to ask several questions. Those who answer them correctly, will explain everything, will get small gifts. So, watch the slides carefully. So, what's the most interesting thing? Our speakers don't even know about these questions, so you may not even ask them for help. So, let us start. The first. Not to make any mistakes, I would like to invite on to stage our first speaker, Wolfram Bernhard from company Metso, please.
Well, ladies and gentlemen, thank you very much for this invitation and for presenting what we are doing within Metso in developing the technologies for concentrating so-called critical materials. Okay, just a bit of the introduction, what the presentation will contain. So a little bit information about Metso, test work and process development, how we do it. Some examples, a few examples about tungsten processing flow sheets, yeah, and then what our portfolio is to support the industry to extract the resources and the minerals and the metals in a sustainable form. Okay, Metso, I think, is well known, but we are a global acting company serving aggregates, mineral processing and metal refining industry. And the headquarters is situated in Espoo in Finland. We are listed on the stock exchanges also in Helsinki. And our target is to sustainably support our clients to sustainably extract and process the ore they mine. The key numbers for during 2024 is we had sales of 4.9 billion euros, yeah, which was generated in 50 countries. The EBITDA was 16.5% with 804 million euros. Generated by 17,000 employees, and the Metso Plus sales. These are products which have the target to efficiently process the materials using less energy, using less water, using less natural resources. The sales, you can see, we have evenly distributed between all the regions: Europe, Asia Pacific, North and Central America, South America, and Africa and Middle East. About 75% of our sales are generated in minerals, 25% are generated in aggregates. So what are we doing? We are fully offering solutions for the mining industry and also for the aggregates, yeah, including equipment sales, complete plant solutions, services. We promote and develop sustainable technologies. We serve the industry by our experienced technicians and engineers, and we drive innovation and R&D by our strong engineers and the R&D, which is, let's say, which is on the focus of our president. We are a responsible partner, and we commit that we minimize the hazardous impacts on the environment, on the people, and using optimized solutions for logistics, supply chain, and so on. Okay, sorry. So what our R&D capacities are? We have launched in 2024 24 new products for using more efficient energy, less water, and so on. The investment in research and development was 103 million euros. We have 40 R&D centers and locations. 97.5% of the R&D project is spent on sustainable targets, and we own 7,900 patents. Well, in the focus is the client, yeah? And with a project, and at the beginning of the project, we sit together with the client, we create a concept, we prove the concept, we discuss the result of this with the client. Then we start with the process development, doing R&D work and doing test work. In extended test work, we do process validation, we generate the design data, and finally we do basic and detailed engineering, and finally we hopefully deliver a plant to the client. Yes, we have, as mentioned already, we have a complete laboratory testing and pilot facilities, and the concept we are using is raw materials and chemical characterization, also in terms of mineralogy. We do leaching, precipitation, separation testing, and so on, and to create the data we require to design our processes. So these are the typical process steps we are using here. So we sit together with the client, we do batch testing, we do modeling with our own simulation software, HSC. Then we start with continuous pilot tests, do the basic engineering, go on to the detailed engineering, followed by plant implementation, commissioning and startup, training of the people, of the operators, and finally we offer the services so that the plant can, after handing over the plant to the client, is running smoothly, and we are controlling. We can also control the performance of our equipment delivered to the client. Well, as everybody's talking about tungsten, yeah. So tungsten was the focus. So we thought probably a few tungsten, a little bit of information about tungsten could be useful. And tungsten ore deposits, and the predominant tungsten minerals we have, and we address are wolframite. Yeah? The end minerals are hübnerite, which is a manganese wolframite, and ferberite, which is an iron tungstate. Yeah? very often the wolframite is generated in vein-type deposits, yeah, where it also occurs together with cassiterite very often, and also we have sulfides, we have arsenides, and so on, which sometimes cause quite substantial problems after the refining stages. Here on the bottom, you see a vein-type deposit, yeah, and these black needles here, you see here, these are the wolframite crystals, so tungsten is very coarse here. So these are the vein-type deposits. A bit more difficult it gets when you go to Greisen, yeah, which are tungsten mineralization in silicate rocks, yeah. And here the tungsten, the wolframite is very fine intergrown and causes some issues with the concentration. You can apply different techniques, but for sure flotation is very difficult to achieve here. And last but not least, that's probably of your interest here in Uzbekistan, scheelite. Yeah? Scheelite is predominantly occurring in skarn deposits and stratabound deposits, yeah, and it's finely disseminated in the ore matrix. Well, the gangue minerals are quartz, pyroxene, fluorspar, sulfides, very often sheet silicates, mica, talc, yeah, and this causes a bit of problems, in particular when you have alkali earth minerals there, which is calcite, magnesite, fluorspar, and so on. And because the reagents you're using for flotation of scheelite, they do not attach to the wolframite ion in the crystal lattice, they attach to the alkali metal ion. Okay. So, here we are. One of the first steps is probably pre-concentration. Yeah? So on the left side you see wolframite, on the right side you scheelite. Yeah? So wolframite offers a few options. Yeah? So this is sensor-based sorting. Yeah? So this picture you see up there was taken by me in the Andes on level of 4,000 meters above sea level. And you see the male is doing the hard work with the hammer, and the lady is using the soft skills with the most advanced sensor, the eye, which was developed in a few million years, yeah, to an absolute great performance, yeah, and sensitivity. Other methods we have dense media separation. That's a bit, yeah. And we have jigging. On the other side, we have scheelite. Yeah? There we are very limited. And here we can use sensor-based sorting by XRT, X-ray transmission absorption. And well, the sensors here are very, very advanced. And we can achieve here, we can spot particles up to a particle size of 0.3 millimeters in the ore matrix. Okay, when do we use when is it feasible to use pre-concentration? Yeah, when the liberation of the host rock is coarse enough. If the physical properties, density, magnetic susceptibility of the mineral differ substantially from the physical properties of the gangue minerals. If the recovery losses are minimized, should be less than 5%. Yeah? And last but not least, at least 25% of the gangue minerals should be rejected. Otherwise, the capex and the opex are too high for application of this technology. Well, beneficiation of wolframite ores, we have gravity separation. Yeah, that's what we told in coarse particle size range and in finer particle size range. And as wolframite is a paramagnetic mineral, we use then high gradient or high intensity magnetic separation. Here is an example for a flow sheet. Yeah? So we have crushing, we have pre-concentration by jigs. Yeah? We do recrushing of the jig concentrate. We run cleaner jigs, yeah? And so on and so on. So this is the coarse range, and then the fines are retreated on tables, and finally the concentrate is then sent to the dry magnetic separation part, where we separate the minerals from cassiterite and also most probably siderite. Scheelite is a bit more difficult, so we can use gravity separation, yeah, but only in the fines, and flotation, or we can use this combination of gravity and flotation. And gravity separation provides a high-grade concentrate, up to 60-65% WO3. Flotation concentrates generally on the range between 20 and 50% WO3. Or we can use a combination between gravity and flotation, which enhances the recovery, because seldomly with gravity separation, your recovery will be above 70%. Well, this is now an example for a combined process, flotation, gravity separation. On the lower part, you see the gravity part, and the fines are retreated by flotation. This is in the upper right part. Well, next step is we have, from the concentrate, we use a hydrometallurgical process, and the steps are calcination. Then we dissolve the tungsten mineral. Then we get and turn it from calcium tungstate to sodium tungstate. Then we feed it into a solvent extraction process to produce ammonium polytungstate solution. Then we do crystallizing to produce to turn the ammonium polytungstate into ammonium paratungstate. From APT, we use a we do a heat treatment to transform from ammonium paratungstate into tungsten oxide. Then we do reduction of the tungsten powder from WO3 to tungsten metal powder, and then we do by heat treatment carburation to create tungsten carbide powder. Well, this is this is probably not so good. So this should show the steps between raffination and solvent extraction. Why this happens, I don't know. And what we can provide to you is all the process from the ore to comminution, separation of the minerals, separation of solids and liquids, and also to metal refining. Okay, this is more or less what it is, what we can serve, how we can serve you, and we are happy and here to support you in realizing your project. Thank you very much.
Спасибо большое. Thank you very much for the presentation. Let's move to the next one. The next one will be presented by Alessia Tuzun.
Good afternoon. Thank you very much for staying with us until the very last session of the forum. We also want to thank the organizers of the event, USTMK and Ministry of Mining and Geology for organizing this event. It has been very fruitful. I will be telling you about integrated testing, analysis, and mineralogy on the entire cycle of the mining production. So all of you here are familiar. The modern mining industry is faced with technical and economic challenges. Some of them are due to humanity developing ores for hundreds of years. So we have falling grades, we have increasing ore complexity, we have deeper deposits, so they are harder to develop now. And there are also external factors such as rising energy costs, environmental regulations, and societal expectations. So as a result, more than half of new projects actually fail to achieve the targeted performance, especially when ore variability is unpredictable. It is clear that in the 21st century, the traditional approach where geology, mining, and metallurgy operate separately from each other is no longer feasible, and we need a more holistic approach that integrates the entire testing across the entire life cycle of the project. So we are really lucky now in the 21st century because technology keeps developing, and we have very advanced data collection, data analysis, and modeling technologies tools that help us reduce the risk and maximize efficiency of the mining projects. Now, what do I mean by mining life cycle? So it's exploration, development, production, and then closure and rehabilitation. By holistic approach, what I mean is that at each stage of the mining cycle, you can implement activities that actually directly affect and help other stages of the cycle. For example, at exploration, we can implement the so-called front-loading knowledge to develop early ore body characterization. During development, you can imply geometallurgy, mine-to-mill approach, mineralogy to create the ore body digital twin. During production, you can use real-time process optimization. You can implement AI, machine learning to implement immediate adjustments to the process. And during closure and rehabilitation, you can use a so-called geo-environmental characterization to predict acid rock drainage. So you can actually say that this cycle is not linear, so it doesn't go from exploration to development to production to closure, but it actually looks more like this, where each stage is actually interconnected with every other stage. So we will start with phase one, which is exploration and evaluation. This is a critical period in which foundation of the mining project is laid. And every exploration, starts with geochemistry. So this is when you systematically collect and analyze rock, soil, stream sediments, and water samples to trace mineral deposits at or near the surface. Here, mobile on-site container laboratories are really useful because they can provide really fast results for fast decision making, can be tailored to your specific exploration targets, and can be moved together as your project continues. Our company, Argitest, we provide services for mobile on-site container laboratories, so we can chat about that if you want. Now, in the traditional approach, when your geochemistry is done, your exploration is done. So when you have your economic grade ore, your exploration phase is done. But in the holistic approach, you actually want to also implement mineralogy at this stage from the very early beginning to actually have the very early ore body characterization. So you can actually use mineralogy during drilling core samples, during drilling, to get model mineralogy. So it's the abundance ratios of all minerals present. You can get precious and gangue mineral identification. You can have early textural information, so grain size, locking properties, and detrimental mineral identification. So arsenic, clay, or carbonates that can be bad for your project. So you will know it beforehand. Before actually investing in a project, you will know everything about the mineralogy of it. So you can actually say that this early characterization reframes the definition of discovery, because until now, discovery is just, ore body with your economic grade. But if you imply all of the things that I talked about, so the mineralogy, for example, it's not only an ore body that is economically feasible, it's an ore body that's economically feasible and metallurgically and environmentally feasible. And by investing in this detailed analysis early, the companies can minimize their risks before spending more money on development of the project. Now, phase 2 is development. During this stage, our main goal is to combine data that we already have from our exploration stage with new data to create dynamic 3D models that predict the behavior of your ore body. For that, we are implementing geometallurgical modeling. So geometallurgical modeling is actually, it explores the relationship between geological and mineralogical properties with metallurgical, environmental, and economic performance. As a result, it is possible to characterize variability within the ore body. It predicts the effects of this variability on the process, and as a result, maximize your net present value of the project. Our company, Argitest, we provide services for mineralogical testing, both mineralogical and geometallurgical testing. So we have a range of services, including comminution, classification, gravimetric, centrifugal, magnetic separation, flotation tests, hydrometallurgy, and also engineering consultancy and flowchart design. Here we have a couple of pictures from our laboratory in Ankara. Another thing that you can, powerful tool that can be used during the development stage is degree of liberation and liberation mineralogy. So run-of-mine consists of ore mineral that is surrounded by gangue. And degree of liberation tells you exactly how small you should be crushing your sample in order to have it completely free of the gangue material. Because no matter how efficient your flotation or your leaching process is, you cannot fully recover your mineral if it's interlocked by your gangue material. So it's actually structure that determines liberation that determines your recovery. Here's an actual picture from mineralogy. And that brings me to grade recovery curve. So here you can see on the x-axis is the recovery of your mineral, and on the y-axis is the grade. So everything that is above this curve, so on the upper side, it's not possible physically. So you cannot be like on the upper right-hand corner where the recovery is really high and your grade is really high. So it actually is kind of a trade-off relationship. So you have to choose exactly where on this line you want to be in terms of your recovery and grade. And what's important here is that you can actually get the theoretical grade recovery curve from your mineralogy data. Another really useful tool during development is mine-to-mill or M2M approach. So you know that comminution is the most energy-intensive step of mineral processing. And you can actually start optimizing comminution not at the start of your mineral processing plant, not at your feet, but actually at the mine. So you optimize your blasting in order to reduce energy on the later steps during your crushing and grinding. Here, multi-parameter breakage tests are actually really useful. So we are partnering with GeoPiora for breakage tests that actually use a small amount of sample to perform all of the breakage tests for example, the first 3 are for crushing and the last 3 are for SAG mills, for ball mills, and they are really useful. So as a result, you characterize the ore in the very beginning, and then you optimize your blasting, and as a result, you optimize your grinding. So to summarize, geometallurgical modeling is done in 3 steps. So you have your representative sampling, which should be done under the control of geologists, so that they ensure that your sample is representative for your ore body zone. Then you have your laboratory tests, which are also done in batches according to the zones of the ore body. And then you have your data integration, where you extrapolate your data that you have on hand. You extrapolate it using statistics and get this ore body digital twin. So you have a very comprehensive 3D model, and opposed to the traditional approach, you not only know where each ore zone is, you also know how each zone will be processed, how much each zone will yield, and what challenges it may present. This allows to make strategic investments to the production. Now, coming to the third phase, it's the production. Here you can implement real-time monitoring, machine vision, and scientific AI that you can use to enable immediate adjustments. It's useful to have a mine site laboratory during your production that is tailored to your specific production. Is accredited, so it's an outside laboratory that is reliable and produces bankable analysis reports. Our company, Argitest, we also provide services for mine site laboratories. We can chat about that later as well. And then last phase is rehabilitation. So for rehabilitation stage, is you want to leave behind an area that is chemically and physically stable and not polluted. And for that, you need to predict your acid rock drainage. So this is when sulfuric acid is formed. And in the traditional approach, you use static and but the problem with those is that they all assume that all of the sulfide is pyrite. However, it's not always the case. This is when advanced mineralogy comes into play. That can be done as early as on the exploration stage. So you do your advanced mineralogy, and then you can actually quantify the amount of specific sulfide minerals, like pyrite and pyrrhotite. And then, because they have different reaction rates, you can determine exactly and predict your acid rock drainage better. And you also can determine your surface area of acid-producing neutralizing minerals as well. So as a conclusion, in the 21st century mining, integration of all of the stages in geochemistry, mineralogy, and geometallurgy is not an option, but a fundamental requirement for the success. And we are proud to be your partner at each stage of the mining cycle, together with our global technology solution partners. Thank you very much. If you have any questions, you're welcome to chat later. Thanks.
Thank you very much for your interesting talk. Let's move to another next talk.
I'd like to invite for the next presentation Nikolai Ganov from Thermo-Techno Engineering. We're going to present his talk. Good evening to you, ladies and gentlemen. I'd like to thank Tatianazis very much especially warm feelings I would like to express to the participants of this audience who until now haven't lost their appetite to get new knowledge. And in my presentation, I would like to talk about automated labs. We are not going to talk about the commercial labs, but rather factory-based labs, express labs, central labs. What is the normal procedure in making up balance of metals? Every department of mining plant has its own idea and own figures. People are compiling their reports, but metal balance is the strongest. Those who have the most authority and trust are either so-called mining shop or the chief enrichment officer or chief metallurgical officer. It's different with different enterprises. If all the processes starting from uh, sampling, sample preparation, analysis, all the stages are made according to all the norms, it does not happen. Every unit following their samples gets a report. This report could be sent through LIMS system, but all the results are made in the robotic lab, which has no influence from any participants, interested participants or clients. So the report is 100% truthful and reliable. So metal balance also is a result is reliable. The market of automatic labs in many estimates grows, and this is one of the references I found on the internet. So what's the difference between the hand lab, where yes, all the tests are made according to all the norms and according to all the methodologies of analysis on one hand, and robotic lab on the other hand. One of the companies in South Africa made a great big job before buying a robotic lab. They have analyzed a big amount of samples, and this is the left side graph where you see, well, specifically separated types of ore, four types, ore as an ore that comes to a plant, uh, residues as residues that came as an ore. It's not the bad option as well, and most negative results when the ore was certified as waste and immediately sent to tailings or tail deposits, and the enterprise was losing big money. And why it happened? Because the difference between the two samples, certain trusted interval under hand preparation of samples and analysis was quite large. And robotic system narrowed down these trusted intervals, so the results were more reliable. And this is the right-hand side picture. So less volume of ore, which was good as an ore, was not wasted into tailing. Even if you take this 1% of all the cases, if we recalculate 1% of the 10 million tons, it is going to be very, very big money. How can automated lab look like? Ideally, automated lab start from sampling. Sampling could be made from a conveyor, from the sample tower when the samples are taken 1 ton and the tens of kilos or 5 kilos could get into the lab. Then this sample could be prepared in the lab like drying. Then the sample could be crushed, separated into during several stages. After every stage, archive sample could be taken, then packed. In final stage, we have crushing to 71 micron, and then sample could be separated and packed into two envelopes. So all the robotic system can operate with the barcode. Therefore, operator will not have to rewrite the samples every time, and robotic system would be responsible for that. One more, maybe one of the most important advantages, if we talk about the powder samples, is that after every stage of sample taking, the machine could be cleaned by compressed air or anode material. The sample before preparation at the crusher or mill could be weighted and weighted afterwards. Therefore, there is always a difference. Some of the sample stayed inside the machine, and which part? If 10 gram out of 1 kilo, we believe it's good. If 15, then the LIMS would put a red flag, and the operator would have to do something about it. Either this sample was not completely dried out, or there were some other reasons. And this is a signal would be uh, wrong, and the wrong analysis was out. So this could be this way when from different stages of flotation the samples are taken. First, leakage from mill, then industrial products and concentrates. In this case, there were 12 points of sampling engaged into this process. After the sample taking, the pulp was delivered to the lab. There it was dried. No, first dehydrated and press filtered and dried out, separated into three parts. First part was going to gravimetric analysis. Second part was going as the archive daily sample, collected sample, and the third part was going to um, uh, powering and into X-ray spectrometer. The full analysis cycle from the beginning of sampling was about 40-45 minutes. And that's example of concentrating of appetite 4. We can automate not the whole lab completely. It would be too expensive and sometimes even inefficient if we're talking about 300, 400, 500 samples a day. Under such pressure workload, we recommend to automate the most difficult parts, such as, for example, crushing, separation, and turning into powder or powdering. We have the same capacity, but the machine takes less area, and respectively, the workload on to personnel is rapidly goes down. So, talking about the liquid samples or preparation of samples to atomic absorption analysis or nuclear absorption analysis for spectrometrics with the connected plasma, where the samples are first dissolved, then the dissolving process is quite lengthy, as normally female hens are doing that. The process is actually harmful for health and is strongly dependent on the operator's mood. So this process is desirably to make automatic as well, not just solving of samples onto analysis, but also it is desirable to automate the analysis of uh, uh, turnover water. At some plants, it's made best case once a day. However, even once a day, this parameter is changing. There are several examples and photographs of how it may look like in 3D modeling and live photographs. You can make automated chemical plastic analysis, classical wet chemical analysis, granulometric analysis, phase analysis, and element analysis. The main value of solution based on robotic lab is impartiality. You get results with no impact from any interested parties or stakeholders. After 30 years of communicating with personnel of labs and with the lab users, these are enrichment plan people, metallurgical people, cement people, I had an impression that if you standardized raw material delivery to a plant, so the chemical component and so on is standardized, then the lab is not needed. And technology solves all the matters. It's been prepared, and all the technological processes are automated. Thanks God, this is not the case in real life, and the role of the lab in controlling technological process is extremely important. So, automated lab allowed to get results faster, in more precision, and trusted interval is much less. Thank you very much for your attention. If you have any questions, we're having our stand out there. Thank you very much for your presentation. Yes, in terms of the question, we assume that the questions would be at the end of the session, so you may write them down, accumulate them, and ask them to our speaker later. Let's move to our next presentation. Ilim Baktipekov from MicroMine Central Asia would be our next speaker, please. Good afternoon, dear colleagues. Let me present myself. My name is Galin Baktibekov. I'm the operation manager of MicroMine Central Asia. And today's my presentation is dedicated to two products, MicroMine Lines, two planners, MicroMine Last and MicroMine Advanced. One of them is intended to be working in open mines, and second at the underground operations. So this slide shows the whole line of MicroMine products, starting from geological exploration to operator control. I'm going to speak about the two of them. At first, let me tell you about the MicroMine Alastri. This slide shows you 5 modules, and every module is in charge of its own sets of tasks. First module, Rapid Reserver and Fold Infinity, is served on the preparation of initial data for planning, following tactical scheduler and production scheduler. This is where the planning of mining is going on, like both short-term and long-term planning. And special conformetrics is made for analysis of compliance of actual surfaces to the plan of production works. And this slide, module Rapid Reserver, it uploads all the project contours, it uploads all the block models. This could be not one block model, but a complex, so the planning could be done not along just one specific pit, but in complex along several sections. So we have a separation onto extraction blocks. It has record of geological data from the models, and at this stage you can get certain enlarged estimation about what deposits are going to be used for planning, and then splitting of the block could be made in automatic mode and in manual mode, and so on. Next module is called Whole Infinity. It allows to get digital model of transportation scheme of the mine pit, and you can create reports about time of transportation of cargo and a report about fuel consumption. So there is an opportunity to digitalize completely based on actual data your transportation scheme, pointing to all reloading points. This could be different warehouses or temporary warehouses and so on. In every road section, you can set speed limits and other limits. It takes into account the slope. You can model up choosing a particular set of equipment like excavator and a truck, how much time is spent in cyclical mode, how much time the truck would be loaded, unloaded, and waiting to be loaded. So you can get such kind of analysis. The next slide. At the next slide, we are showing tactical scheduler. This is the mid-term planner from 3 months until the whole time, completely integrated comprehensive solution and preparing reports given prepared deposits and modeled transportation network. The module allows to make optimized planning with given limitations, targets, and also allows to have comprehensive optimization of drilling works, taking into account the transportation of the ore mass with mixed fleet and so on. And here we are showing the data flows that come into this module. As I said earlier, with Rapid Reservoir and Whole Infinity, from Rapid Reservoir we'll get data on the deposits. These are blocks from Whole Infinity transportation scheme. And in tactical, this would be processed, establishing some strategy and the plan. And when establishing the plan itself, there would be an opportunity based on the prepared data. We can make some different scenario based on different limitations, consequences, sequences, and so on. And at this stage of analysis, we would be able to choose the most appropriate option to develop the mine works. Next module is module called Production Scheduler. It is intended for short-term calendar planning of mine works from 3 months up to weekly and daily planning. It is working on a hybrid presentation on Tican diagram and 3D sequence. With that, we have full integration with external databases and with operational ones. There's a chance to track and analyze the compliance to long-term plans. Also, there's a visual presentation of technological process of your production with immediate reflection of updated data. And the module includes a capacity of simultaneous planning of explosion, drilling works, production, processing, enrichment of the raw materials. In the production schedule, unlike the tactical one, we have many steps of setting and adjustment, intending to double checking, specifying things which correspond to midterm calendar planning. And this is actually a demo of this module. It works based on Gantt diagram. And the final module that I wanted to talk about on software micro mine illustrate is spatial conformatrics. It works based on carcass models So we upload actual carcass models, and this must radar data using the shootings, and we also upload carcass models which are planned to work out. And we match this carcass data and we set up these reports. This reporting could be established in 3D way, and what you can see here on the slide, and we can make it up in a table format.
The next chapter of my presentation is a different program. It is called MicroMine Advance. This is underground mining planner, and we know that planning the groundwork is not just schedule. It's logistics, resources, security, equipment, deadlines, and MicroMine Advance combines all this into one single unit. You don't just build a plan, you check it for feasibility, visualize and analyze the impact of each decision. This is not just replacement for Excel or CAD. It's whole environment where you can build a realistic plan, visualize it, and quickly make changes. And Advance is designed specifically for underground mining operations, taking into account logic, dependencies, scenarios, and production constraints. Engineers spend hours reconciling tables, making edits in CAD and Excel, and manually connecting the fragments. In most mines today, mining planning looks like this. We have a we have some block model, separate graphs in Excel, separate drawings, and separate reports. And everything is not connected to each other. Any change requires time, checks, and there is always a risk of error. Advanced combines all this into single environment. You change the scenario with the graph, reports, visualization, and technique are recalculated automatically. In the video, we see the center lines with the sequence of penetration, and Micromine Advanced doesn't just draw workings, it takes into account machinery, shifts, speed limits, drilling and loading equipment capabilities. The planner immediately sees if there are enough resources, how many dump trucks will be needed, and where a conflict is possible. And this gives you confidence that the plan can actually be completed and not just make it and create it. The work in the system begins with the construction or import of center lines. Next, we build a sequence of penetrations and dependencies. Now, this allows you to build a logical and technologically sound development sequence. Based on the design cross sections, the system automatically creates 3D workings, which, if necessary, can be supplemented with geological data from the block model. And animation is used for visual control and flexible setting of development priorities. For example, from the upper sub-level is implemented using the specified dependencies and restrictions. This allows you to accurately reproduce the production logic of the enterprise. One of the greatest strengths of Micromine Advance is working with scripts. You can create as many training options with different rates, training, and transportation. They all live in the same environment and do not require separate projects. You can quickly compare scenarios based on key metrics, volumes, resources, deadlines, and efficiency, and immediately show it to the team or management. Separate summary tables are designed to analyze equipment utilization, and they display operating hours, downtime, overloads, and help determine whether there are enough resources to complete the plan or whether the fleet needs to be strengthened. At the same time, a comparison is possible both within one scenario and between several. To complete the assessment, the financial analysis is provided. The built-in module calculates costs and revenues for each type of work and raw materials, generates cash flow, and calculates NPV and net present value. In the process of calculating the steps, it is going in the plan run consists of two stages. The first is to create an online schedule which takes into account only the geometry of the deposit without restriction on equipment and volume. And next, the last step is to adjust all resource and equipment constraints to create a realistic plan. Micromine Advance it's capable of giving different kind of report form depending on your needs and having the information in database. The planner can form any reporting you need. So the next slide demonstrates the video. So according to the desire of a customer, the script was the script was added, and this way it was automatized the process where the planner actually spent more time. So my last slide. What benefits does using MicroMind software give a business? First, faster and more reliable planning, fewer mistakes, rapid adaptation of new employees, the ability to see what happens if, and make decisions based on data, not assumptions. Plus, it reduces the time for recalculation, improves communication between sites, and makes the plan fully transparent. That's it. Thank you very much for your attention. And thank you very much, Galim. It is a very interesting presentation. I really like the animation which you have. I have one wish for Micromine. I can send you feedback form of popular services. There are navigators, and you can choose like horse or someone else. So you can also make this option. Maybe you'll have it later in your later versions. Yes, as the time was limited, I was trying to make it. Yeah, but I hope you will put there some minimal icons instead of excavator. So the next speaker is Denis Ivanovich Shamov, Lab company, please. Colleagues, good afternoon. Thank you very much for organization this event forum, and also thank you very much for being present. I think you are very strong staying to the end. I would like to share about our offering which we actually made for this mining industry based on our product Labware is a global international company which is developing program software Labware Links, and it is focusing on it, and it in the LIMS system, it's first place on the market. More than 21% of the total sales volume of software of this class LIMS. Our product is present in 5 continents and more 150 countries present. More than 2,500 companies use our product every day, and customer retention rate is more than 98%, and for more than 30 years we are present on the market, and the company are working with us all the time. So 100% private company, and we have offices across the world. Of course, the headquarters in USA. We also go to European regions, Manchester office, and we Latvia. We also have office in Russia, and we recently opened our representative office in Kazakhstan. So Latvia, Russian company, the only one in the CIS countries authorized by the global company Latvia Perform. In full range of services, sell software Latvia, provide software implementation services Latvia, provide technical support for software Latvia, and conduct trainings for our Russian-speaking customers. We work in Russia in CIS since 2006. The basic questions in the laboratory, it's increasing performance, reducing the cost of performing routine tasks, analysis, effective resource management, reduce paper use, like paperless turnover. It's integrating innovations, simplifying laboratory processes, reducing risks, elimination of manual entries, automated data entry, and of course, it's compliance with state and environmental regulations, compliance with yes, standards like ISO 17025 and other regulatory requirements. And of course, decreasing efficiency. It's rapid identification of samples, fast decision making, and ensuring complete traceability, and also across the laboratory, and also improve product quality. So our main tasks during the implementation test is research objects, geological samples, its technological samples, its evaluation of ready products, and attestation, assessment of the products, and so on. And with all these tasks, we have the class of software products limbs. So you can see that in IT structure of a company, it's like mass, it's a middle level. Between between RPA and SBS. So it's a laboratory information management system, and here it serves as a primary source of operational reliable data on product quality for the enterprise production services, and the system helps to really manage the laboratory processes with some triggers and so on. So the system is also serves as a primary source of operational and reliable data, and of course product quality for the enterprise production services. And when we integrate, because we work in different industries, we wherever there is a library, we also have a solution, and we use this industry solution. It's a modules more than like a lot of modules we have, and the combination of these modules and some other preliminary settings which are actually characterized in this industry. In this combination, it's like a bridge solution or sector solution, which is reducing the time for integration the product and to start the project from the level. And this, together with our colleagues, we also made a solution for the mining industry and create solution, Lobby Mining says, which includes a set of industry-specific modules. It's a configured standard industry business processes, more than 80 prepared reporting forms, specialized training for staff, the documentation package with instructions on working with all functional blocks, and much more. An industry solution like Bear Mining says allows you to standardize business processes and significantly reduce project time frames. And we, of course, followed the best practices, our foreign experts, and the best world practices, and we of course have some peculiarity. We have localization. We also have our internal requirements in science countries, and we also had good experience of integrating like Krasnomed, Polius, Katsink, UKTMK, and we of course took it into consideration and made the decision where we include, according to our experience, the best processes which are very appropriate to this industry. It's of course, managing the personnel and compliance and accreditation and other parts which are very appropriate to the mining industry. So they already there. It's a set of industry-specific models. We can just take it out of the box and use it. So we will just take just few because we have a limitation on time. So it's registration of samples, different ways to register in the system. There are different scenarios. It can be register. It's also automatized according to the graphic of analytical control. In our system, we have the editor with the marking, so we can use a different kind of format. You can see how it can be put. The label can put on samples. You can also set it up. Then when we make the registration of samples and go to archive, for example, arbitrage or archive sample in the system allows you to create a digital twin of the archive and where you can always track the position of the samples, their placement with details down to a specific archive cell. And also like immediately you can react. For example, there is a time for utilization of the sample, so you can make control operations with samples, characteristic, testing for expiration dates and relevance. And there are different various interfaces for entering results. It's automatic checking for compliance with specification limits, which is in the system. Customizable visualization of entered results in results entered space, possibility of converting values when changing units of measurement, and of course, the entering results automatized with any laboratory equipment. This interface is automatically you can gather and analyze them and automatically calculate them according to this methodology. And accounting of precious metals is one of the projects which we have in the solution. All the weights after these precious metals, we can also put it when conducting tests. The system takes into account the loss of precious metal for analysis. And this is then displayed as a user safe and manual write-off precious metals has also been implemented. And to also work, it's one of the most important. It's managing equipment management because every equipment must be accounted, and the system allows us to make this process very simple and easy. And the laboratory equipment accounting and all information is already here. You must just enter the data according to the equipment and just update this information. For example, if you have the certificate for this kind of equipment or others, so you just put it into the system, so update the data. Then you will always have this monitoring, segmentation of schedule for inspections, collaborations, maintenance, identification. The next one is document management, which is being used in laboratory. You can also put it in the system, and there is a mini system document management, which is it's not just keeping the document, but also help you to develop the document. So when you are working to develop on methodology, you can set up the process, what people, what personnel has access and make edits in the document, who will confirm the document, and etc. Everything according to ISO standard. Control charts. So this is data in real time. And analysis of trends and also Schucher's map, and it's automatic notification, and there are a lot of reporting form which are there, so you can also use this reporting form and you can also adapt them according to your processes. The support of digital signature, the reporting forms such as protocols can be signed using an electronic digital signature. Document signed with an electronic digital signature has the same legal force as one signed manually. Integration with third-party ISN devices, so we are not limited here. We have if the system can be integrated, of course we will integrate it, and we will put connection. One of the solution, which is working like a reminder notification with information, is integration with the integration with Telegram bot. So the ability to integrate with has been implemented Telegram by API and sending information from links to it. And for example, you can send alerts about non-competitors or when the trigger is there. So the notification bot is in Telegram channel, so you can quickly make corrective measures. So it's a ready-made kit of documentation, which is also going with this solution. Of course, the benefits, advantages or benefit solutions when we use the solution, it's like out of the box. We can really integrate for a short period of time the universal technical solution corresponding to the need most of the industry's client. Thank you very much for your attention, and I will be glad to reply to your questions. Thank you very much for your presentation. Let us move to our last speaker. And then if you have any questions, we will give reply. We will try to give reply. Okay, now we are going to present to Dilshad Saitov, Mito Consultancy Company. Good afternoon, dear participants. My name is Dilshad Saitov. I'm very glad to present here.
Our company works for more than 17 years. We help enterprises in mining energy sectors. Nifta is engineering environmental company. We support projects at all the stages from the very beginning. We help to get expand license. Then we do environmental studies, prepare documents for investors and for the government. We control construction and production of process, and afterwards we develop safe plan of closing the mines. We open not just in Turkey but in other countries including Europe and CIS countries. Our values and features in the basis of our activity, we have fundamental values: protect the environment, modern approaches, site-specific design, given biological and social peculiarities, optimum solutions, and consumer focus for every site. We are certified following the main international standards. We have PIA qualification, authorized legal entity, YQT in Turkey. We also have environmental certification and documentation. We provide multifunctional engineering consulting services, SIA studies, planning, mine planning, geotechnical studies, GIS, tailing and leaching, R&D, hydrogeology, and other services. In the framework of common and single hydrogeological consulting, we may study on geochemical modeling, water structure design, water supply studies, water drainage. We cooperate with universities of Turkey and Europe. Biodiversity, tailings and closing, mine closures, we can develop plans, management plans for large projects, identification of flora and fauna, monitoring of ecosystems and components, and action plan on biodiversity, rehabilitation of tailings, developing the mine closure plans, and heap leach closure plan, and waste management plan. So we calculate we do air quality monitoring, noise measurements, air quality measurements, soil quality monitoring, studies, sustainability reports. In our projects, we analyze material objects, intangible contour, inheritance, design according to international standards. We develop mine consulting, environmental and mining law, also construction and maintenance and operations. During our years of operation, we adopted 100 projects: gold mine, graphite mine, multiple reports following the orders of International Financial Corporation, EBRD, international private investors. So what we did, studies, provided calculations, created models, submitted documents, developed plans on mine closure. Dear colleagues, Community Consulting is a company which is comfortable to work with. We are flexible, reliable, and open to new challenges. Thank you very much. Dear colleagues, our presentations are over. Now we have time. We're almost fit into agenda timing. We have time for several questions from the audience to participants. Please, if you have any questions, raise your hands. No questions from the audience. Then let me ask you a couple of questions with your permission. I have a question to Denise. Denise, as far as I understand, you can try to turn the microphone on, press the button. Yes, yes. Great. I understand you develop your product, and probably you're not standing still. Yes, indeed. How often do you have updates, if any? We have a new version for our main product. It is issued every 3 to 5 years. Our modules also are updated regularly, so we have regular updates. Our company follows the trends, whatever we have in the lab, IT technologies, we're using everything. Now we have an active mobile version, so working it out, and we are developing it at the moment. Thank you. Maybe some of you have questions from the audience. Then I have a last short question. So, is it possible to import any of the side micromine products? Very briefly, yes. In particular, I talk about micromine illustrator. From the side product, we can import different block models, also carcass models. Not necessarily could be our product micromine. This could be a side software. Micromine allows through gets it, processes it, then builds internal file micromine raster, and then it is reached for planning. Thank you for the detailed answer. Now, very briefly, something I promised. Arthur, please, 5 more minutes. If you don't mind. For the lottery's sake, yes, it's not quite a lottery. Now I would like to ask questions to the audience. To be honest, I will try. Those English speakers need to use the devices for simultaneous interpretation to be fair, because I'm going to ask questions in Russian. I hope everybody's ready. My impro skills. Who knows the answer to a question will not be difficult. Let me tell you up front. Don't shut them out. Raise your hand. The hand I see first will get a chance to answer. If the answer is wrong, next hand, and eventually we get to the right answer. I hope we'll get it quickly. I hope everybody's ready. The question: how many presentations there were during the last session? Raise hands. Here. Microphone. Do we have a mic? 6. Right. Correct. It was quite simple. That was the warming up question. A small gift. Please come here. A bit more difficult, but I promise it's still going to be simple. Everybody's ready? Yes? Same rules. But there's one little but. Raise hands, those but from Metsa company. Raise hands, those of you who are from Metsa. We will find it out later after. Anyway, right. Please, you don't participate in this question. Where is the headquarters of Metsa? The city. Raise hands. I don't see it right here. A woman? Helsinki. Wrong answer. Who's next? Person, a man. A man from Metsa. No, not Metsa. This is the hand. Please. Hello, everybody. Good evening. Vespa, Finland. Yes, let us give a round of applause to the most attentive person. And here I also have a personal prize for you. Representative of Metsa, please also come. There were any hard feelings for you? Like that, let me finish our session and the forum as well. Arthur.